All right, so you just did the first one there. This one is pretty similar to the first one. So why don't you just read the question at the top there, and then we can get started.
All right, sounds good. So a self-dividing number is a number that is divisible by every digit it contains. For example, 128 is a self-dividing number because 128 mod 1 is 0, mod 2 is 0, mod 8 is 0. Also, it is not allowed to contain the digit 0. Given a lower and upper bound, output a list of every possible self-dividing number, including the bounds. Yeah, so it makes sense. I don't think I have any questions, but I think an approach to this would be to have a helper function that detects if a number is self-dividing, and then in the main function have a number that you increment, and after calling the helper function, if it is a self-dividing number, then you would increment that variable.
Okay, yeah.
All right, so to start, I'm going to say what the helper function will take and do. I'm going to write this in pseudocode and then write the actual code. So helper function will take a number, and since we're in Python, it could be, doesn't need to name a type. So going to detect if there, oh, that's not how you comment. Detect if there's a 0 in the number. You're also going to check, I'm going to use a while loop, I think, or no, we can just use a for loop to go through each number. And I think what I'm going to do is I'm going to cast the number to a string so that you can use the idea of for x in number.
Right, yeah, that works.
Okay, so I'm going to do that from the beginning to check. Cast to string to use for x in num. Detect if there's a 0, and then check if the mod of each digit is 0. And if all of those is true, then it is a self-dividing number. So then return true. Yeah, so that'll be our helper function. And then in the self-dividing, we're going to have a variable for incrementing. And for every call to helper, if it returns true, well, we're going to send each number between lower and upper to the helper function.
Okay.
I'll put a list of every possible self-dividing number. Okay, so we're going to make a for loop to send to the helper function each number. And if the helper function returns true for every number that you send to it, then you're going to, well, the prompt just says to output a list. So should we create an array, or do you think that we can just do a cout for every number that?
Yeah, so the return type for the function on line 16, the main function for this one, will be a list. So you want to have a list of all of the self-dividing numbers.
Okay, so we're going to initialize a list. And since we're not sure how many numbers we'll have, we want it to be the maximum possible number. So we're going to say that's going to be a size of upper minus lower.
Okay, in Python, you can just initialize an empty list. It's not like C where you have to allocate the memory for it. So you can just like append it to it every time.
Oh, okay, cool, great. So we don't have to initialize. For loop send, and then, yeah, so then I guess at the end of it, we'll just return the list and everything should be all set from there.
All right, cool. Yeah, why don't we start writing it up then?
All right, sounds good. So initialize our lists. We want to say it's going to be a list of ints, but we don't have to name the type. So we're just going to call it list. Or variable for incrementing, we're going to call it.
So yeah, line 9 is how you initialize the empty list there, just so you know.
Okay.
Yeah, there you go.
And then we're going to say, we don't actually need this variable for incrementing since we're not counting the number of them that are, we're just actually telling the people what they are.
Yep.
So for all right, so we want to go, I'm thinking in C++ right now, but if we're going to go from the lower to the upper, we like my thought process would be to just do a simple like for loop like this for int I equals.
Okay, yeah. So just for syntax stuff for this one, you can just use range, and you can say for I in range, and then set your bounds.
Okay.
In range. So.
So for x in range, lower and upper, we're going to call helper at x, and we can shorten this by saying if helper, because that's going to return a true or false. So if true, then this, we're going to append to this list x. And at the end of all that, we are going to return the list.
Yep, so for 26, I put the syntax at the top there, just l1.append x like that.
Oh, okay, yeah.
Yeah, I know what you mean though, so it's fine.
Okay, cool.
Okay.
And now we're going to fill in our helper function. So we're going to cast the number to a string. Detect if there is a 0 in the number. So we're going to say for x in num, if x equals 0, return false. And when we return false, that's just going to be a quick way to say this is definitely not a self-dividing number. So okay. Our first check, check if the mod of each digit is 0. So we're going to check. Actually, we can do all this in this one x for loop. So if x equals 0, return false. Next check if x mod, or no, if num mod x equals 0, return. Well, we can do these as a I'm thinking that we want to do all of these until we get a result of false. So I'm thinking that we need a while loop somewhere.
I think you can stick with the for loop here. So just think of the conditions that you want to return false. And then if none of those are true, then you can return true, right? Or I should say if none of them are false, then you want to return true.
Okay. So if x is 0, or if x num the mod the x is not equal to 0.
Yep.
Then return false. And then else we don't exactly want to return true just yet because we want to go through all of the x's.
Right.
So, how about we get a Boolean variable here? So and there's no else condition because we just want to go through the x. Go through all the x in the number. And then we're going to initialize this to true. So it's going to be true unless there's a condition that makes it false. And then if nothing makes it false, then we're just going to return the variable, whatever that might be, or false. Return var. Yeah, and then that's going to be the end of our helper function. One of these, I think, or no. Okay, so string the number, bool the var to be true for all x and m, and num if either the x is 0 or if any number makes, if it's not divisible by any of the x's, then return false. So otherwise, return true. Yeah, so I think that should work. And we are calling our number there. Do I need brackets here? I think I just need a colon, I think.
Yep. Yeah, you get the colon there, yeah. And then, okay. So I see the logic is good. This will work. There's some syntax stuff that I won't necessarily hold against you just because of, I know you're mainly C++ recently, like you said. So basically the true falses are capital T or F. You'll see it syntax highlight. And then, okay, so on line 19 here, there's one bug, I think. So what is this first conditional there, the first check, x double equals 0?
Mm-hmm.
So what is the type of num here?
Oh, it's a string. So you can't use that kind of operator on a string.
You can use the operator, but I think the 0 there needs to be changed a little bit.
Okay, so I think we want to put quotations around it.
Yeah.
And same for here.
So I think this one was good without this, but there is another little thing. So remember, x and num, right? They're strings, like you said.
Yeah.
So num here is going to be a string. So, and so is x. So you're calling mod on two strings here.
Okay, so maybe I'll cast that back to, I mean, that's a lot of casting though. Maybe there's a better way to do this. I guess we could just cast it to be an int, right? So that we could use the modulus operator.
Yeah, so you can cast it, but the only thing here is this will still be a string when it is executed. So.
Okay. So,
I think if you move this, then, because this actually, another small thing, you do have to reassign it. But let's just move this somewhere so you don't need to do all this crazy casting here. You will have to cast one thing, but.
Okay, so num comes in as a string. Definitely want to cast that at some point to be, I mean, num comes in as an integer. We want to cast to a string at some point. We only need to cast it as a string to do this.
Right.
So, for x and num. So you're saying that we should move that statement?
Yeah, I think 15 could be moved somewhere. So that way we don't need to worry about casting num and x here. We just need to cast one of them.
Just cast one of them. Okay.
So what is the purpose of line 18 here?
To iterate through all of the integers, all the digits in num.
Right. And then, so that would make x a string, right?
Yeah.
So is there any other time that we need, basically this, casting this to a string here would not change the num data type. It would just make x an iterator that is a string of size 1 a character if you want. So what I would do is just change this to str, if I can type that, right? And then when we get here, num is still going to be an integer, so this mod is good except for one thing.
So x is still an integer and num is a string, but we want to convert num back to an integer so that we can mod with it. So we'll cast num back to an integer. Oh,
so num right here, because this doing this does not actually change the type of num. It is just going to exist as a string in order to iterate through this loop here. So num is still an integer here on line 19. But
okay.
X is going to be a string here.
Okay, and we want it to be an int, so we can cast X as an int right there.
Yep. There you go. Now I think this is a perfect solution. This will work as we expect. So the data types get kind of weird. So, you know, you just got to make, like, I think this also might have just been like a Python thing that you may not have been familiar with. So it's not a big deal. But like, if I just type this here, if you print num on the next line, it will still, this would still be an integer. Or if I even just printed the type of it, for example, then if num is 0 here, and then I called this line, this 14 there would still give you int.
I see. Okay. So unless you reassign it, it's really just like changing it for that one purpose you need for that.
Just that instance there. So here we're changing it just for this instance, so that way we get X as a character or a string of size 1, right? And then that's why we can do this check for a character, and then, but it allows us to not have to do something like this where we have int num, int x, and all this craziness of casting. So it kind of just makes it a little bit cleaner. I mean, at the end of the day, I would still give this a pass because the logic was there and correct for the whole thing. So again, it's just like a little Python syntax thing. So depending on the interviewer, they might care more about that, but I just care about the logic, and that was good. So I think you're good. But anyway, so now the fun part, what is the time and space of this?
So time and space, well, we're saying x in range. So we're going through every x, so that's at least constant time. And then every time we call the helper function, we go through x in the number. So it's constant time multiplied by the number of digits in num.
Okay.
So would that be squared time, like n squared?
It would technically be n times m, but I'm just going to assume that n is our the total amount of digits. So we'll just keep it order n just to make it easy. But technically, yeah, it's n numbers times m digits. So.
Okay.
And then what about space here?
Space. Well, we are creating this additional array. So It would be constant space because it's predictable from the outset that it's only going to be no bigger than your upper and lower, like the size of between your upper and lower bounds. So I would say that's constant space.
Okay, but you said that it's deterministic on the bounds here, right? So when we were doing the time complexity, n is our lower to upper bound, right? The total number of numbers.
Mm-hmm.
So in big O notation, this is big O of what?
Oh, it would be big O of n because it depends on n, right?
Right.
Okay.
Yeah. All right. Well, good job. I think in terms of any like feedback, I would say just, I think we kind of decided on Python. If you're more comfortable in C++, then run with that. Just so you don't, because basically, at least from my own personal opinion, the logic is what really matters. And you came to that really quickly. And the rest of this stuff of all this casting we did and whatever really kind of comes down to like syntax. So that's not like super important for me personally, but if you keep running with Python and that's going to be your go-to interviewing language, then make sure that the syntax is like second nature, just like speaking.
Okay.
But that's the only like little nitpicky thing that I have. Other than that, I think you did really well.
Great, thank you.